Hi guys, this video is going to be one of two of your last videos for this unit. Thanks for watching all the videos that I made, and also thank you for those that provided feedback for them. This video will be done primarily on the computer, and then my last video will be done on paper and pencil, the old archaic method. And while we're working on this, you should have this sheet out, and we're going to jump to this bottom part. How does tangent relate to the values on the unit circle? So what I have here is I have the unit circle on GeoGebra. I have a point on the unit circle. The point is 0.69, and what that's referring to is going to be my adjacent side. That's how long it is for the x. The 0.73 refers to the height of the point. Now this point is 0.81. The reason I have 0.81, this angle is 46 degrees right now. If we put 46 degrees in radians, that's 0.81 radians, and ignore the degrees. So when I drag the point up to 0, 1 at a 90-degree angle, you'll see alpha be 90 degrees, and you'll see the radians as a decimal be 1.57. So let me show you that. So again, at 90 degrees, you have radians of 1.57 degrees. Now, you might have noticed that this other point moves, so let me tell you about this point. The 0.94 refers to the radians. The 1.38 refers to the tangent. Now, the tangent, remember, is opposite divided by adjacent. So what I did is I took 0.81, I divided it by 0.59, and I get 1.38. What GeoGebra is going to do is it's going to take all those numbers. So now it's 0.77 divided by 0.64, and I get 1.21. And what it's doing is it's plotting. This blue point is going to show the radians on the x and the y over the x value on the y value. Our job is to see, as I move this green point around on the unit circle with one full revolution, what's going to be happening to this point. So before you try to answer that, and if you answered it out loud, nobody heard you. So let me drag this point and just watch what happens, and then I'll do a couple other things to see. You don't need to write anything down on your paper right now. So interestingly, if you take a look back, it looked like the point started at 0, and then it goes up. So now the y value is 3.21, that's why it's moving up more. The radians are 1.27, so the x values are starting to go to the right. And as I keep going, look at this value. The opposite divided by adjacent is just a huge, huge, huge value. And then the second I take it past 90 degrees for the green point, my value of tangent is now negative. That makes sense to me because the first quadrant, all the values are positive, and the second quadrant, the tangent values are negative. And there's the point again. And we see it again, and then it disappears. And if I zoom out, you'll see it one more time. And then it starts back at 0 again for another revolution. So what I want to talk about is why that's happening. And what your paper is asking is for you to, so how does tangent relate to the values on the unit circle? So please go ahead and pause the video. I hope you were able to put a good response. The tangent relates to values on the unit circle by taking the opposite side and dividing it by the length of the adjacent side. Please flip over your sheet. You're going to next plot the values of the tangent at labeled locations here, and I'll guide you through where to plot these. And once you're done, I'm going to put a graph of what tangent looks like so you can see it a little bit better. I did put a little note here that when you do 1 divided by 0, you're going to positive infinity, and when you go to negative 1 divided by 0, you're going to be going to negative infinity. Let's start at this point here. When the radians are 0, your opposite adjacent value is 0, which means my blue point, which is the one you want to watch, will be at the origin. Please spot a point right there. I'm going to go to pi over 4 next. Now pi over 4 is the same thing as 45 degrees. So watch this alpha. When I get to 45 degrees, that's when I'm going to stop. Okay, it's going to be about there. The radians in 45 degrees will be about 0.79 radians. Your opposite adjacent value will be 1.01. My next point is going to be pi over 2. Pi over 2 is the same thing as 90 degrees, so let's see what that value is going to be. This was the one where I do 1, the opposite value, divided by my adjacent value, and I get a big number. That big number is going to be infinity. So at 90 degrees, the y value is going to be way up here. The next part, I'm going to keep dragging this point around, and notice the value now is negative. Let's go on and get to 3 pi over 4, which is about 135 degrees. (135 degrees is about 2.37 radians. Let's see if we can get a little bit more accurate. 2.36 radians, and the y value is going to be negative 0.98. So at 3 pi over 4, we're going to get a negative 0.98. It's weird how this point jumps from here, from a positive infinity, down to a negative value. And it's almost like there's a little line that can't be crossed here. That little line that can't be crossed is going to be called a vertical asymptote. Remember, and I just want to talk about this for a minute, tangent of x is equal to the y values divided by the x values. Notice that x can't be 0 here though. So if x cannot be equal to 0, that means I am going to have a vertical asymptote at pi over 2, and the graph is going to start down here again to reset, and then start going like that. Let me graph 5 pi over 4. 5 pi over 4 is the same thing as 225 degrees. Notice what happens when I get to pi, 3.14, at 180 degrees, or 3.14 radians, my tangent value is 0. I'm going to plot that right in between here. I'm sorry. I'm going to plot it right here. Ignore that point. Now let me take you to 5 pi over 4. That's about 1.01 for 3.93 radians. So 5 pi over 4 is going to be about 1.01 again, which will be about right here. I'm sorry that I'm not applying the points in the right spot. That might be due to something like it's 5:30 in the morning. And now I'm going to take this back to 3 pi over 2. And 3 pi over 2 should send this up to infinity again, which it does. Notice this is negative infinity this time, but if I drag it just a little bit to the right, I am going to a positive value. So on the graph, the tangent value will look like that. And then it will repeat. So that's where I get my negative infinity. And then it starts out at a negative again and crosses back at 2 pi. So the tangent value starts at negative infinity and goes like this. And 7 pi over 4 will have the same tangent value as 3 pi over 4. So this is what our graph should look like. Let's take care of the last few questions. Please state an interval where a complete cycle on the graph occurred. Next, looking at your last package, please answer determining the domain and range of the arctan function. You may pause the video to do so. So the domain of that function will be all real numbers for arctan. The range will be negative pi over 2 to pi over 2. The domain and range of a function relate to its inverse by switching the y's and the x's, which means that your domain for tangent will be from negative pi over 2 to pi over 2, and your range will be all real numbers. So I wrote it in here for you. From negative pi over 2 to pi over 2, that's going to be your domain for the tangent graph. All real numbers will be the range for the tangent graph. And this is what tangent looks like. It's going to be these little dancing waves that are always interrupted by a vertical asymptote, and then they just repeat each time. And if I was able to do negative angles on here, this blue point would trace over all the other points that you have here. Please go and graph this on your worksheet. Skip the amplitude. That should not be on the graph. One period of this function takes place from pi over 2 to 3 pi over 2. That is a distance of pi units. So your period of the function will be approximately pi units. The domain of the function is all real numbers except for pi over 2, any multiple of pi over 2, and your range will be all real numbers. You can't have any multiple of pi over 2 because if you did, you can't have any multiple of pi over 2 because if you did, your y value would exist, your x value wouldn't, and then you'd be getting that vertical asymptote because you'd have a 1 or a negative 1 divided by 0. Your range, we can see that the y values, even if I zoom out, we can see that the y values will go on forever in the north and south direction. Thanks for watching the video, and I'll see you for the last one.